So, good morning, one and all. Today's topic is series positive and negative clippers. Okay, so today we are going to study about series clipper. This series clipper is of two types. In this series clipper, we will study about two types, that is unbiased and biased. In that, we will study about related to positive clipper and negative clipper. Okay, so now we are going to study about the first concept is series negative clipper, unbiased. If you have not mentioned anything, it will relate it to unbiased clipper. Okay, series unbiased clipper, sorry, series unbiased and negative clipper. That means the name indicates that it is a series clipper. That means the diode should be in series to the load resistance, and the name indicates that it is a negative clipper. That is, the negative portion of the input signal will be removed. We will see how it will be done. The circuit will be like this. See here the circuit. The diode should be placed like this, and this is the load resistance RL. Because it is a series clipper, we have to draw in series. This is the positive terminal of the diode and this is negative terminal of the diode. Here I am applying the input voltage, V input. Okay, this is the series negative clipper circuit diagram. Here I am applying the input signal. I am applying a sinusoidal signal. This is the V input and x-axis is time period. This is applied as input to this circuit. Okay, what will happen? Now you all see this one. When you apply a positive half cycle, if you apply a positive half cycle to this circuit, what will happen? The positive terminal of the diode is connected to the positive voltage. Then the diode will act as a short circuit. Then the diode will act as a short circuit. So all the input voltage will appear across the output load resistance. Okay, so the output equal to V input. If you apply a negative half cycle of the input and the x-axis is time period. Okay, if you apply like this, see here the negative half cycle, that is the negative voltage is giving to the diode positive terminal. Whenever you give a negative voltage to the diode positive terminal, that means it is connected in reverse bias, so the diode will be in open circuit. Then the diode will be in open circuit. Then all output equal to 0. There will not be any output across the load resistance because it is open here. Here the diode is short circuited. So from this we can understand that the transfer characteristics of this clipper is the transfer characteristics. The transfer characteristics is nothing but the graph between the output and input voltages. The graph drawn between the output voltage to input voltage of the circuit is called as transfer circuit or transfer characteristics of the circuit. Here I am applying the input. You all can see here. This is the V input voltage of a sinusoidal signal. I am applying. Okay. See here. Okay. Now, what will be the output voltage? From this circuit, if you apply this as an input, so I am explaining about the input and output waveforms. After that, I will discuss about the transfer characteristics also. Okay. So this is the input and output waveforms. This is the input and output waveforms. Okay. After that, we will discuss transfer correct. This is the input waveform and I'm drawing the output waveform. This is the time. So now, so during the positive half cycle and during the negative half cycle, we will observe what will happen. If you give the positive half cycle to this diode, the positive terminal of this diode is connected to the positive voltage of the input, then the diode is in forward bias. So it is short circuited. So all the input will be appear across output. So whatever the input you are giving, the output also getting the same output. Okay, the sine shape. During the negative half cycle, whenever you are going to apply a negative half cycle, then what will happen? The negative voltage is given to the positive terminal of this diode, and the diode is acting as a reverse bias, so the diode will be open. So the no input voltage will be appear across the output. So the output equal to 0. Again the positive half cycle. So again the positive half cycle will be present, and during the negative half cycle, so during the negative half cycle, you can see here again it is in 0 and again positive half cycle. That means from the output waveform, what you have understood, the negative half cycle of the signal has been clipped. That is why it is called as a series negative clipper. Okay. So the transfer characteristics will be like this. See here. The transfer characteristics of series negative clipper. So I have defined that the transfer characteristics is the graph drawn between the output voltage to input voltage, V output and V input voltage. Okay, so here we must have that this is 0. So during positive half cycle, what is happen? The diode output voltage is equal to the input voltage. So it is conducting. So it will be like this. So during the negative half cycle, the diode is not conducting. It is in 0. Okay. That means here the diode is in off. In this condition, the diode is in on. Diode is in on during this period. Okay. This is the transfer characteristics of an ideal diode. That means if you select it as a default, it is an ideal diode, it will start from 0. If it is not an ideal diode, what will be the transfer characteristics? So the transfer characteristics for a non-ideal diode. That means transfer characteristics of non-ideal diode. What will happen? So for non-ideal diode, it will conduct after the cut-in voltage of the diode. This is V input and this is V output. Okay. So the diode will conduct after the cut-in voltage. If it is made with a material of germanium or silicon, there will be a different one. So 0.7 volts cut-in voltage. Okay, for if it is material is a silicon. If it is a germanium material, it will be from 0.3. So the diode will conduct from 0.7. It will not conduct from 0 if it is not an ideal. So during the negative half cycle, the diode is off. So it will be like this. So the diode will start conduct from here. Here the diode is in on. Okay, so during this period, diode is in off. Okay, so this is the transfer characteristics for a non-ideal diode. Is it clear, everyone? Okay, all of you understand the series negative clipper. Once again, I'm going to revise. So in this series clippers, we are going to study about two types. One is series positive and negative clippers. Today we have discussed about the series negative clipper. So this is the circuit diagram for a series negative clipper. For this circuit, I'm applying a sinusoidal signal. So in that, first I'm applying a positive half cycle to the positive terminal of the diode. Then the diode will act as a short circuit. So the output voltage will be appeared, all the input voltage will be appeared at the output. So from the input and output waveforms, you can see here. Here I have drawn, whenever the positive voltage is given, the output is all same as that of the input. During the negative half cycle is applied to the circuit, the diode is in open circuit. Then the output voltage is 0. Because the diode is open, no input will be passed through the load resistance. So during the negative half cycle, the output is 0. So the same process will repeat for all the positive and negative half cycles. So this is about the input and output waveforms. So whereas the transfer characteristics of an ideal diode. If it is a diode, if I am using a diode as an ideal diode, it will conduct from 0. So during positive half cycle, the output waveform is present. So the diode is on during this positive half cycle. So I am showing it with a linear increasement. So during the reverse bias or negative half cycle, the diode is off. So I am showing as 0. If it is not an ideal diode, if I'm using not an ideal diode, what will be the transfer characteristic? The diode will conduct from 0.7 if it is a silicon material. Diode is made with a silicon material. Okay, or if it is a germanium material, it will be 0.3 volts or something. So it will conduct from 0.7. It won't conduct from 0 like as ideal diode. This is the difference between these two characteristics of ideal and non-ideal diode. Thank you.